polar form of Shear equations. Shear equations means Cauchy-Riemann equations. Polar form of Shear equations is, the statement is like this: if f of z equals to u plus iv, that is a general way of u plus iv is general form of Cartesian form. But here we are going to discuss z is nothing but here r into e power I theta. I already discussed what is r, square root of x square plus y square. What is theta? Tan inverse of y by x. Okay, so here this f of z also can be writing in the form of u plus iv, but earlier we discussed Cartesian form. U and v are in functions of x and y variables, but here u and v are in functions of r and theta variables. R and theta variables. R and theta variables, and f of z is differentiable, and f of z is differentiable at x at z not equals to, at z not equals to r naught into e power I theta naught, e power I theta naught. Okay, then the Shear equations are, the Shear equations in polar form are dou u by dou r equals to 1 by r into dou v by dou theta, dou v by dou theta. And the another Shear equation is dou v by dou r equals to, dou v by dou r equals to minus 1 by r into dou u by dou theta. These are the two Shear equations in polar form. Okay, these are the things. So students, first I'll give you how to, what is Milne-Thomson's method. I'll just give you like a procedure. I'll just give you like a procedure. You can note down that also. So here main heading is construction of analytic function. Construction of analytic function, main topic name. Construction of analytic function. What is analytic function? F of z. Construction of analytic function whose real or imaginary part, real or imaginary part provided, imaginary part is known or provided, is known. That means, what is the real part of f of z? U. What is the imaginary part of f of z? Is v. So if u is given, how to find analytic function? Or if v is given, how to find a analytic function? That is our concept. Already I told you how to, okay, what are the concepts we are going to learn in this unit, and the main concept is that only. Okay, now in this there are two ways. First way, I am using Milne-Thomson's method. Milne-Thomson's method. Milne-Thomson's method. What is this Milne-Thomson's method is? I am giving you the process. I am explaining the procedure. Let f of z equals to, let f of z equals to u plus iv is the general form of our function. We know that. Okay. Then, if this is a thing, then this is the general one. Okay. If they are providing u, then how to find it? If they are providing v, how to use this Milne-Thomson method? If u is known, u of x comma y is known. Okay, that means u is given in the problem. Then we need to find f of z. Then we need to find f of z function. Okay, so how to find that is, if u is given, we have to take here dou df by dx equals to dou u by dou x plus I into, okay, what is, let me repeat it again. Okay, now you are having equation, okay, this is f of z equals to u plus iv. Taking it as equation number 1. Can I partial differentiate the equation number 1 on both sides with respect to x? If we partial differentiate on both sides with respect to x, then what we will get? What we will get? Partial differentiate equation 1 with respect to x on both sides. Then if we do partial differentiation, what we'll get? Dou f by dou x equals to dou u by dou x plus I into dou v by dou x. Okay, this is the thing. But what they are going to, okay, once again read the heading of this procedure: construction of analytic function. That means f of z is an analytic function. Is an analytic function. If f of z is analytic, then can you say f of z is differentiable? Yes or no? F of z is analytic, then f of z is differentiable or not?
Yes.
If f of z is differentiable, then f of z function will satisfy CR equations? Yes. So by using the CR equations, here, what is the heading? If u of x comma y is known, then we are following this. So can we find dou v by dou x without knowing v? No, we cannot find out. So how can we find dou v by dou x? By using the CR equations. What is dou v by dou x? What is dou v by dou x?
Minus dou u by
Minus dou u.
Minus dou u by dou y. So using this, I'm going to write in place of dou f by dou x is equals to dou u by dou x plus I into minus dou u by dou y. So finally, we can take it as dou f by dou x equals to dou u by dou x minus I into dou u by dou y. Okay, I into dou u by dou y. But later I'll write left hand side dou f by dou x as a df by dx. I'll tell you why it is. Okay. Actually, here it is. F dash only we can take directly. So I'll tell you later how we are going to get f dash. Here it is. So I'm changing this statement like this: df by dx. I'll tell you later. Okay. So writing here it is df by dx equals to this thing. Next f dash or f dash of z equals to, or simply we can mention like this, f dash equals to, or f dash of z. Now what I'm going to do is here, from the known function u, can we find dou u by dou x? Yes. Can we find dou u by dou x? Yes. Then we will substitute it here. We'll substitute it in this box what we got. Okay. Now by using Milne-Thomson's method, what we have to do is, by using the process of Milne-Thomson's method is, by using Milne-Thomson's method, what we can say is replace x with z and y with 0. Y with 0 in f dash of z. In f dash of z. In f dash of z. What is f dash of z? I'm taking here it is equation number 2. Okay. In this equation number 2, we have to replace x with z and y with 0. Then what is the f dash of z is going to become as in functions of only z variable. Then f dash of z will be only in functions of z. Only in functions of z. Only in functions of z. If that is the case, f dash of z equals to right hand side also in functions of z. So we can use a variable separable method and apply integration on both sides. Then we can get final value. Apply integration on both sides with respect to z only. With respect to z, then we will get f of z function. F of z function, what we require. So this is end of the problem. This is a process. So once again repeating here, if u is known, then partial differentiate. Okay, we cannot mention partial differentiate. We have to mention only f dash of z equals to. We have to mention only f dash of z equals to. I'll tell you later how we are getting it. Okay, so now I'm going to explain case 2. If v of x comma y is known, that means imaginary part is known. If imaginary part is known, then we can say that f dash of z equals to what is the actual formula? F of z equals to u plus iv. So f dash of z equals to dou u by dou x, dou u by dou x plus I into dou v by dou x. Okay, but v is known. Do we know u? No, we don't know. Then in that case, how can we replace dou u by dou x in terms of v? This is CR equation number 2. What is the CR equation number 1? Dou u by dou x equals to dou v by dou y plus I into dou v by dou x. This is a f dash of z. How we have changed this? How we changed this one? since Shear equation 1, what is the Shear equation 1? Dou u by dou x equals to dou v by dou y. So used this point in place of dou u by dou x in the first term, I changed dou v by dou y. Then what is the actual concept taking this as equation number 3? This is another either we can do in case 1 or case 2. So we will not get both the cases in a single problem. They may give u function or v function in the given problem. That's enough. So again, same concept by using Milne-Thomson's method. Milne-Thomson's method, replace x with z and y with 0. If we replace this, what we are going to get? We are going to get f dash of z is only in functions of z variables. Therefore, that implies f dash of z will be only in functions of z. After we get like this, what we have to do? Apply integration on both sides with respect to z variable. On both sides with respect to z variable, then we are going to get f of z function. Then we get f of z function. So what is f of z function? F of z function is our analytic function. This is the procedure of Milne-Thomson's method. Okay, so I'll take a problem and I'll explain, then you can understand what I'm going to, what I want to mention here. So here, okay, I'm taking here a problem. Find an analytic function. Find an analytic function. Find an analytic function whose real part is e power minus x into sine y minus y cos y. This is the problem. So before we are going to discuss this, what is the general form of analytic function? F of z equals to u plus I. Be an analytic function. Be an analytic function. If they provided an analytic function, what is u here? What is u? Real part of f of z. What is v here? Imaginary part of f of z. So where u is equals to real part of f of z. And what is v? Imaginary part of f of z. Imaginary part of f of z. So from the given problem, what they given here? U is given or v is given? What we can understand? U is given or v is given in our problem? U is given. So given u equals to given u of x comma y equals to, what is u of x comma y? E power minus x into sine y minus y cos y. This is the thing. Now here, what we need to find? What we need to find? We need to find dou u by dou x and also dou u by dou y. Whatever the function they give us, if they give u function, find out dou u by dou x and dou u by dou y. If they give us v function, find out dou v by dou x and dou v by dou y. That's enough. Nothing else we don't need to worry about it. So dou u by dou x. So if we observe, e power minus x is in functions of x, and the second factor is also in functions of x variable, and also y is in functions of x. Okay, but here we are taking, okay, oh sorry, not y is in functions of x. Here we are taking partial differentiation of u with respect to x. Then we have to treat y as constant. Yes or no? Y as constant. Now we have to apply differentiation of uv. What is u here? Okay, e power minus x is u, nothing but this is one function. Okay, and this is another function. Both are in functions of x. So we have to apply differentiation of uv formula. When we apply the differentiation of uv formula, what we are going to get? U into, what is u? E power minus x into. What is the differentiation of v? Nothing but differentiation of the second factor. So differentiation partially with respect to x. Treat y as constant. What is the first term? Sin y is constant. What is the differentiation of x with respect to x? Is 1. Minus, what is the differentiation of y into cos y with respect to x? Partially 0. So finally what we will get here? Dou u by dou x equals to e power minus x into sin y. Sorry. This is only dou u into v dash, but u dash into v kuda kavali kada, plus this is u into v dash plus u dash. What's the differentiation of e power minus x? Minus e power minus x into u dash into v. V will be no changes. X into sin y minus y into cos y. Then I am doing some simplification. E power minus x into sin y plus 0 or minus 0 minus x into e power minus x into sin y plus y into e power minus x into cos y. This is just our dou u by dou x. Is there any simplifications we can do it? We can take e power minus x into sin y common. That's enough. So no need to worry about that. Otherwise, if you want, you take e power minus x common. So dou u by dou x equals to, taking e power minus x common, then sin y minus x into sin y plus y into cos y. This is the thing. This is just dou u by dou x. Now we need to find dou u by dou y. For finding dou u by dou y, check it out. In the above function, u function, we are having two product of factors. What is the first function? E power minus x. Is it e power minus x contains a y variable? No. Then what can we take? So I'm taking here partial differentiation of u with respect to y partially. Then e power minus partial differentiation with respect to y, treat x constant. So e power minus x constant into this x also constant. Differentiation of sin y is cos y minus inside the brackets y into cos y form. We have to apply here differentiation of uv formula. Y into cos y. What is that? Here it is, y into cos y is there. So to this we need to find differentiation of uv formula. U into, that is y into v dash is minus sin y plus u dash is nothing but 1 into differentiation, okay, simply cos y. So this is only second term expansion. Now rewriting this and removing all the brackets, then what we are going to get? Okay, I'm putting e power minus x as it is, e power minus x into cos y minus y into sin y. First term is minus y into sin y. Minus y into sin y multiply with minus 1, we'll get plus y into sin y plus minus 1 into plus cos y. Multiplying minus 1 with cos y, then we'll get minus cos y. So this is our dou u by dou y. Dou u by dou y. Now putting this one also in the box. Okay. And now according to the procedure, when u is given, what we have to take? What we have to take? When u is given, what we have to take? Check it on the screen. If u is given, what is f dash of z? Or dou f by dou z? Dou u by dou x minus I into dou u by dou y. That we can take as a formula directly, or we know that simply we can take as, we know that f dash of z equals to, we know that f dash of z equals to dou u by dou x plus I into dou v by dou x, but dou v by dou x we don't know. Converting it into dou u by dou y only using Shear equation number 2, dou u by dou x plus I into minus dou u by dou y. Minus dou u by dou y is a product of I. So if you are not putting any brackets for this, then it will be wrong. Okay. So substitute dou u by dou x and dou u by dou y values here. That implies, what is f dash of z? F dash of z equals to dou u by dou x. What is dou u by dou x from our first box, which is available on the screen? E power minus x into sin y minus x into sin y plus y into cos y minus I into plus I into minus dou u by dou y can be written as minus I into dou u by dou y. What is dou u by dou y? E power minus x into cos y plus y into sin y minus cos y. This is f dash of z. Now, what is the process we need to use? Milne-Thomson's method. They didn't mention in the problem Milne-Thomson's method, but we are going to use the Milne-Thomson's method. By using Milne-Thomson's method, what we have to do? What is the Milne-Thomson's method? What is the Milne-Thomson's method? What we have to replace?
X with Z.
X with Z. Replace X with Z and Y with 0. If we do this, then what we are going to get? That implies f dash of z equals to e power minus z into sine, what is the y value? 0, minus x is nothing but z into sine of y is nothing but 0, plus 0 into cos of 0, this is only first term, minus I into e power minus z into what's the next? Z into cos 0 plus 0 into sine 0 minus of cos 0, because y is equals to 0. So on simplification, we are going to get f dash of z equals to e power minus z into, What is the first term? Sine 0 is 0. Second term also 0. Plus 0 into cos 0 is 1. So we'll get 0 only. Minus I into e power minus z into what is the cos 0 value? Is 1. Plus 0 into sine 0 is also 0, minus cos 0 value is 1. So finally, we are going to get first term is 0, everything, minus I into e power minus z into z minus 1. Z minus 1. Okay. Now, okay, wait. Now, if you observe, finally, what is f of z? F dash of z we are going to get f dash of z equals to minus I into, okay, I'll take minus I inside the brackets. Okay, minus only I'll take inside. Then it will become I into 1 minus z into e power minus z. This is f dash of z. After getting f, what we discussed in the procedure f dash of z is, we discussed in the procedure what we are going to get in f dash of z. Then we will get f dash of z will be only in functions of z variables. Then apply integration on both sides with respect to z. Then we'll get f of z function. Okay. So using that point here. So apply integration on both sides. Apply integration on both sides. With respect to z variable. Then when we apply integration with respect to z variable, then what is the left hand side is going to become as? Simply f of z equals to I into integration of 1 minus z into e power minus z into dz. Okay, better I'll write integration of f dash of z into dz because of the first problem. That implies integration differentiation gets cancels. We'll get f of z is equals to I into, what is the integration of uv? Nothing but integration of f into g. What is the formula of integration of f into g? F into integration of z minus integration of z into f dash. So what is the f function we have to take and what is the g function we have to take? I, L, A, T. So what is the algebraic function here? 1 minus z is the algebraic function. E power minus z is the exponential function. Exponential function is the last function. So f into, what is f? 1 minus z into, what is integration of e power minus z? E power minus z by minus 1 into minus integration of f dash. What is integration of f dash? What is f here? 1 minus z. 1 minus z differentiation is minus 1 into integration of e power minus z is e power minus z by minus 1. Okay, is equals to less than 1 minute is there, students. So if the meeting closes, please rejoin with the same link. Z minus 1 into e power minus z minus this minus 1 gets cancels. Okay, this minus 1 gets cancels. So what is the again integration of e power minus z into dz? What is the again integration of e power minus z into dz? E power minus z by minus 1. E power minus z by minus 1. Then on simplification, we will get here, I am separating all the terms, z into e power minus z minus e power minus z plus e power minus z. Then what is going to become finally? That implies f of z equals to I into z into e power minus z will left. But in your differential equation, so same process we have to do for whenever they provides v ichina kuda ide process. Okay, so f of z equals to, I am taking only f of z. I'll tell you about plus c later. ప్లస్ సి గురించి తర్వాత డిస్కస్ చేద్దాం. I into z into e power minus z, e power minus z. సార్ క్లాస్లో ఉన్నా కొంచెం కాల్ చేస్తా, 3:30 కాల్ చేస్తా, రైట్. So here I am going to write what is that? X plus iy. I into x plus iy into what is a exponential of minus of again x plus y. Okay, so if we do some simplification, then what we will get? Xi plus I square y plus I square y becomes as minus y into, how can I write this e power minus x into e power minus iy. Now tell me, anybody can remember what is e power I theta? You can unmute and you can speak. What is e?
Cos theta plus I sin theta.
Yes, very good. E power I theta equals to cos theta plus I sin theta. But when it comes to e power minus I theta, cos theta minus sin theta, these are the things only you learned in your intermediate D Morgan. Okay, D Moyer, something like that. So now I'm going to write that one, e power minus x into xi minus y into e power minus iy. I'm going to write as cos y minus I sin y. Okay, now here there are two brackets. One is the open brackets and another one is the closed brackets, but both are complex numbers. Product of two complex numbers is again a complex number. So I'm going to get that complex number here like this, e power minus x into, how to multiply two complex numbers? Product of real part. What are the real part of x minus iy? Minus y. Minus y multiplying with cos y. And okay, minus y to multiply just now first, then we'll get plus iy into sin y. This is the first minus y to multiply just next, multiplying with xi plus xi into cos y minus xi square into sin y. Okay, now I'm going to substitute x square, I square is equals to minus 1. I'm going to substitute I square is equals to minus 1. Okay, so on simplification we are going to get e power minus x into, can I separate the real parts? What is the real part? This is real part. Is it this is real part or not? Second term is imaginary part. So this is also real part. So why I square is, I is there, but how, why I am saying it is as a real part? Because of I square can be written as minus 1. Okay, so first I am writing the last term here. So minus x into minus 1 is plus x. X into sin y minus y into cos y. Next, plus I into. Now observe here, I am underlining these two terms. I am underlining with the pink color with these two terms. So from these two terms I am taking I common. If we take I common, what we will get? What we will get? X into cos y plus y into sin y. Okay, now tell me how I can write f of z equals to e power minus x into sin y minus y cos y plus I into, okay, plus I into x cos y, sorry, not x cos y, e power minus x undi kada common ga, e power minus x into x cos y plus y sin y. Now tell me, check what is the real part in this f of z function. This is real part. What is imaginary part? This is imaginary part. Check what is the given problem. What is the given problem in our u function? What is the u function they given to us? E power minus x into x sine y minus y cos x. X sine y minus y cos x. E power minus x into x sine y minus y cos x. Cos y. Is it u function? This is only we got. Now tell me, is it our problem answer is correct or not? Yes. But still I am having a doubt. No, not given. Let f of z equals to u plus iv is an analytic function. Is an analytic function. Okay, given v of x comma y equals to log of x square plus y square plus x minus 2y. Okay, so what we discussed, whenever they give u function or v function, what I mentioned, immediately find out dou v by dou x and dou v by dou y if they given v. If they gives u, immediately find out dou u by dou x and dou u by dou y. So finding dou v by dou x. How to find the dou v by dou x? Partial differentiation of v with respect to x, treat y constant. What's the differentiation of log of x square plus y square? 1 by x square plus y square into differentiation of x square plus y square with respect to x partially, treating y constant. So what we will get here? We'll get simply 2x plus differentiation of x with respect to x is 1 minus 0. So finally we will get here, we'll get dou v by dou x is equals to 2x by x square plus y square plus 1. This is dou v by dou x. And dou v by dou y. Dou v by dou y is equals to partial differentiation of v with respect to y. So again we'll get same manner, 1 by x square plus y square into differentiation of x square plus y square with respect to y partially is 2y. Simply x is constant plus differentiation of x with respect to y partially 0 minus 2. So finally we will get 2y by x square plus y square minus 2. Okay, this is the thing. Now after getting this one, what we need to do, what I mentioned, what is the procedure? Students, I said you, I'll give you later how we are getting it. For that there is a lot of proof. Okay, so remember like this only. We know that f dash of z equals to dou u by dou x plus I into dou v by dou x. This is actual formula. But how to write this one? What is a given function? Is u or v? V is given. But here dou u by dou x. How can we find dou u by dou x? We cannot find. But since from the CR equation 1, from CR equation number 1, what can we say? Dou u by dou x equals to dou v by dou y. So what we'll get? Dou v by dou y plus I into dou v by dou x. Why we are using CR equation? Anybody can say why we are using CR equation? Because f of z is differentiable. Why f of z is differentiable? Because f of z is analytic. F of z is analytic, so f of z is differentiable. If f of z is differentiable, then both the conditions of CR theorem will satisfy. Now going to substitute here dou v by dou y and dou v by dou x values. So dou v by dou y value is 2y by x square plus y square minus 2 plus I into dou v by dou x is 2x by x square plus y square plus 1. I is common for both the terms. That means two terms here. Now, according to our discussion, which one we have to use here? Milne-Thomson's method. By using Milne-Thomson's method or by applying Milne-Thomson's rule, one second. M-I-L-N-E. Milne-Thomson's method. What we have to do? What we have to do here? Replace x with until unless you are not responding, then there is no use of I am explaining here. And y with 0. With 0. Okay, so now if we do this, f dash of z equals to 2, y value is 0, 0 by 2 into 0 by z square plus 0 minus 2 plus I into 2x, x is nothing but z, 2z by z square plus 0 plus 1 plus 1. So on simplification, I'll get here like first term is 0. What we'll get finally? 0 minus 2 plus I into, this is 2 students, not z, 2z by z square, then we'll get 2 by z plus 1. So this is f dash of z. What we discussed earlier in the procedure, f dash of z will be only in functions of z variables. And then how to do our problem? How to do our problem? As we discussed, integrate on both sides, apply integration on both sides, with respect to z variable. Then if we apply integration on both sides with respect to z, I am writing left hand side direct step. Okay, this I'll write one more problem like this. Integration of f dash of z into dz equals to integration of minus 2 plus 2 by z into I plus I into dz. So f of z equals to minus 2z plus 2i into integration of 1 by z into dz is nothing but how much? You can unmute and you can speak. Log z plus I into z. So what is the final f of z function? Therefore f of z equals to iz, okay, I minus 2 into z plus 2i into log z is required analytic function. Required analytic function. So tell me students, shall we discuss one more problem on? So here now we need to find analytic function whose real part is sine 2x by cos h2i minus cos 2x. So here considering let f of z is taking as u plus iv is an analytic function, and given u real part is given, so u of x comma y is equals to sine 2x by cos h2y minus cos 2x. This is the u function. After taking the u function, after they are providing the u function, what we need to find? Dou u by dou x and dou u by dou y. So dou u by dou x equals to partial differentiation of u with respect to x. Treat y constant. Numerator contains x variable, denominator also contains x variable. So do here differentiation of u by v formula. If we do the differentiation of u by v formula, v into, there is a cos h 2y minus cos 2x into one second, v into u dash. What is the differentiation of sine 2x with respect to x?
Two cos 2x.
Yes, 2 cos 2x. 2 cos 2x minus u into v dash, sine 2x into v dash, denominator differentiation with respect to x. So first term is 0 minus cos 2x differentiation is minus 2 sine 2x. So it will become plus by denominator whole square we will get. So that is v square, cos h2y minus cos 2x whole square. So now we need to do some simplification. One minute, students. Got an important message. So we need to do simplification. While we do the simplification, what we will get? Here it is. Now cos h2y into 2 cos 2x. So 2 cos h2y into cos x minus 2 cos square 2x minus sine 2x multiply with the 2 sine 2x. We will get 2 sine square 2x. Now, if you observe, the last two terms contains minus 2 cos square 2x minus 2 sine square 2x. So from that two terms, what we will get it? What we will get it? Simply 2 minus 2. So 2 cos 2x into cos h2y minus, I am writing simply 2 after simplification. How we will get 2? Because of taking minus 2 common, we will get cos square theta plus sine square theta. What is the sine square theta plus cos square theta? Since sine square 2x plus cos square 2x is equals to 1 because of this. Okay, theta may be anything. Whole by denominator is cos h2y minus cos 2x whole square. Taking this as a dou u by dou x. Same manner we need to find dou u by dou y. So can we expect that similarly dou v by dou y is equals to, wherever x is there y, wherever y is there x. Can I take like that? Yes or no? We cannot take like that. Dou u by dou x. So this is u function. Now we need to find dou u by dou y. So numerator sine 2x is constant because doing partial differentiation with respect to y, treat x constant. So numerator will be constant. Sine 2x is constant. And then if we observe, denominator is like 1 by ax plus b form. Then what is a 1 by x plus b differentiation with respect to x? Minus 1 by x plus b whole square into differentiation of x plus b. So same manner, minus 1 by cos h2y minus cos 2x minus 1 by cos h2y minus cos 2x whole square into, again differentiation of cos h2y, again differentiation of cos h2y minus cos 2x with respect to y, partially with respect to y. Treat x constant. What is the differentiation of cos h2y? Differentiation of cos h hyperbolic. What is the differentiation of cos h? It will be sin h or minus sin h.
Sin h, sir.
Plus sin h only. So plus sin h to y minus differentiation of cos 2x with respect to y partially is 0. So finally we are going to get dou v by dou y is dou u by dou y is equals to, on simplification, minus sin 2x, minus 2 sin 2x into sin h to y whole by cos of cos h to y minus cos 2x whole square. This is also required in our f dash of z formula. So what is the next step of the procedure we need to take? We know that f dash of z equals to, f dash of z equals to dou u by dou x plus I into dou v by dou x. But according to the given problem is u function. So we are having dou v by dou x and dou v by dou y only. Dou u by dou x and dou u by dou y only. So dou v by dou x we have to rewrite it as minus dou u by dou y. By using which property? Since by second Shear equation. By using second Shear equation, writing this, then we will get here simply, that implies f dash of z equals to dou u by dou x minus I into dou u by dou y. Now substituting dou u by dou x and dou u by dou y here, dou u by dou x is a 2 cos 2x into 2 cos h to y, 2 cos 2x into cos h to y minus 2 whole by, denominator is a cos h to y minus cos 2x whole square minus I into dou u by dou y is a minus 2. So can I write it as plus 2 into sin 2x into sin h to y whole by same denominator here also, cos h to y minus cos 2x whole square. Okay, so now what we have to do? By using Milne Thomson's method, replace x with z or x by z and y by 0. Okay. So if we do this, we get f dash of z equals to 2 cos 2z cos h of 2y, y value 0. So 2y is nothing but 0, minus 2 by cos h 0 minus cos 2z whole square plus 2i into sine 2z into sine h of 0 by denominator will be the same. So in the next step, both the denominators I'll nothing but I'll take LCM form like that. Cos h of 0 minus cos 2z whole square. Now, if I combine, that means indirectly, if we are taking LCM in the denominator, then we'll get what is the cos h0 value? What is the cos h theta formula? E power theta plus e power minus theta by 2. So what is the theta value here? 0. Cos h0 e power 0 plus e power minus 0 by 2. Better wait a second. I'll remove this. I'll write this is as a important step because this thing is required for us. Now, similarly, what is the sine h theta? What is the formula of sine h theta? Sine h theta equals to e power theta minus e power minus theta by 2. Same manner, sine h0. So in place of that, we are having zeros, e power 0 minus e power minus 0 by 2. E power 0 is nothing but 1. So finally, what we'll get? 1 minus 1 by 2 is equals to 0. Whose value is 0? Sine h0 value is 0. Okay. Same manner, here, what we are finding? Cos h0 value. What is the e power 0 value is 1. 1 plus e power minus 0 is also 1. 1 plus 1 by 2 is 2. So taking it is as 1. Cos h of 0 is equals to 1. Now substituting these are the things in our previous step. That implies f dash of z equals to writing LCM a single function like we are taking as a LCM. So here it is LCM is 1 plus cos h0 is 1. 1 minus cos 2z whole square, cos 2z whole square. This is the denominator, and numerator will be 2 cos 2z into cos h0 is 1. So finally 2 cos 2z minus 2 plus I into anything is there. Sine h0 is 0. So everything will be 0. Is it clear? So plus this everything is 0. Now can I take a, okay, can we do any simplification here? Students, can we do any simplification here? Sorry, this is a 1, not 1 plus 1 minus cos 2z denominator. 1 minus cos 2z whole square. Check it out. 1 minus cos 2z whole square. So if I take 2 common in numerator, then what is going to become? If I take 2 common in numerator, we are good. Okay, minus, we can do taking 2 common, then what we'll get? Cos 2z minus 1 by, how can we write a minus b whole square? B minus a whole square. Can I write a minus b whole square as b minus a whole square? Cos 2z minus 1 whole square. Then this term whole power 1 and denominator square gets cancels. So finally we'll get f dash of z equals to 2 by cos 2z minus 1. Cos 2z minus 1. Even if you take minus 2 common in numerator, then we'll get 1 minus cos 2z. That 1 minus cos 2z and denominator 1 minus cos 2z gets cancels. Then we are going to get finally same minus 2 by 1 minus cos 2z only. Okay, is a required analytic function. required analytic function.
For f of z, we make it function.
Sir, we should integrate.
Sorry, yes. We should integrate. This is just only f dash of that function. Now we need to integrate on both sides. So, sorry. How to write? What is the formula of cos 2 theta? Cos 2 theta is equals to 1 minus 2 sine square theta, or it can be written as 2 cos square theta minus 1. Now, which one we will take here? I'm not going to take this. I'm going to take this plus 1 to right hand side. Otherwise, minus 2 sine square theta to left hand side and cos 2 theta. మనకు కావాల్సింది ఏం కావాలి? cos 2z minus 1 కదా. So 1 నే left కి తీసుకొస్తా. What we'll get here? Cos 2 theta minus 1 equals to minus 2 sine square theta. Minus 2 sine square theta. Okay. Now, what is going to become? Is equals to 2 by minus 2 sine square theta. This is theta is nothing but how much here it is? Z. So 2 gets cancels. Then finally we'll get f dash of z equals to minus cosecant square z. Now this is just f dash of z, but we need to get f of z. So applying integration on both sides with respect to z. On both sides. Then we will get f of z equals to, writing left hand side directly, integration of minus cosecant square z into dz. How to find, what is the integration of cosecant square z?
Minus log sine.
What is the differentiation of sine? Cos. Differentiation of cos minus sine. Differentiation of tan secant square. Differentiation of cot minus cosecant square. Minus cosecant square. So minus integration of cosecant square will be cot z. So f of z equals to, sorry, I made a mistake in the previous problem. Plus c. What is the plus c? Integrating constant is required analytic function. Okay. So I'll just modify in the previous problem also. Plus c we have not used, I think. Plus c is required analytic function. We don't know, we are mentioning it is as c. Maybe it may be ci, I into c also. So still any of you are having any doubts, then you can ask. Otherwise, we'll go to the next model. So it is less than 1, 2 is given u function. Given u function, solution. Given u equals to x square minus y square. Whenever they give us u function, as I mentioned, find out dou u by dou x and dou u by dou y. But here we are not finding the analytic function, we are finding the conjugate harmonic function. It is nothing but, first let me check whether it is harmonic function or not. Whether it is harmonic function or not. Finding dou u by dou x. What is the partial differentiation of u with respect to x? 2x only. And also finding dou u by dou y. What is the partial differentiation of u with respect to y? By treating x as constant, minus 2y. and also find out the second order partial derivatives. That implies dou square u by dou x square is equals to 2, and in the same manner, finding the second order partial derivative of u with respect to y. Dou square u by dou y square is equals to -2. Now, can we, what is when we can say u is a harmonic function? If dou square u by dou x square plus dou square u by dou y square is equals to 0. What is the dou square u by dou x square value? 2 plus dou square u by dou y square is -2. So how much we are getting? 0. That implies, what can we say from this? Del square u equals to 0, Laplacian equation satisfied. If a function u satisfies dou square u by dou x square plus dou square u by dou y square equals to 0, then by using the definition of harmonic function, we can say that hence u is an harmonic function. U is a harmonic function. U is a harmonic function. Now we need to find its conjugate. Nothing but v we need to find. V we need to find. So now we need to find conjugate harmonic to u, conjugate harmonic function to u. That is, we need to find v. Okay. For finding this, what I'm going to take is here. What is when we can say u and v are harmonic functions? When we can say u and v are harmonic functions? Tell me. When we can find u and v are harmonic functions? Given function, given u equals to x square minus y square. Now I am finding dou u by dou x. Dou u by dou x. What is dou u by dou x? 2x. Take this as equation number 2. But by Shear equations, Shear equation number 1, what can we say? Why should we have to use Shear equation number 1? Because f of z is analytic. F of z analytic ayindante. If f of z is analytic, then f of z Shear equations will satisfy. By Shear equation 1, we know dou u by dou x equals to dou v by dou y. That I am going to replace here. That implies dou v by dou y equals to, so I am mentioning here equation 2 implies dou v by dou y is equals to 2x. Okay, but now can I do integration on both sides with respect to y variable? Can I do integration with respect to y variable on both sides? Apply integration with respect to y variable. We are not doing differentiation partially. We are doing integration with respect to y partially. Then while we do integration with respect to y, integration of dou v or dv is equals to integration of 2x into dy or dou y. Both are similar, or you can mention dou y into dy. So if we do here, if we do this integration, what is integration of dou v will become as v equals to, what we are going to get, 2x is constant, integration of 1 into dy is y, plus what we will get, we applied integration with respect to y on both sides. So what we are going to get here, integrating constant, yes or no? Yes, but what is it? We made our integration with respect to y variable. So the constant function, whatever the integrating constant may be in functions of x, there is no problem. It is not a problem. Understood? What is that thing here I am writing? Where phi is independent of, phi is a integrating constant and independent of y variable. Why independent of y variable? Because integration with respect to y చేస్తున్నాం కాబట్టి y కాకుండా ఉండాలి. And independent of y variable. Independent of y variable. Now, can I, okay, with respect to which variable we did integration with respect to y? So, do differentiation of v partially with respect to x. Partial differentiate or differentiate equation 3 with respect to x variable. With respect to x variable. Simplify it as c. No, we cannot take it as c. Sir, can we simply take it as c? No. In this case, we cannot take as c. That is only the method. Okay, you can see what we are going to do. Actually, what we need to get v function. If we take v is equals to c, that is phi is equals to c, then problem finished. No, that is not the case. If that is the case, if I am doing partial differentiation of v with respect to y, sorry, with respect to x, then what we are going to get? Dou v by dou x equals to, tell me what we will get. Dou v by dou x, 2y into differentiation of x with respect to x is 1 plus phi dash of x. But now what I am going to do is here, since by CR equation 2, what is dou v by dou x? What is dou v by dou x? Minus dou u by dou y. Yes, students, going to finish in 2 to 3 minutes. Don't need to worry about it. Okay, so this is left hand side. I am going to replace dou v by dou x with minus dou u by dou y is equals to 2y plus phi dash of x. But what is dou u by dou y? What is dou u by dou y? Check it out. Already we got dou u by minus 2y. This is dou u by dou y. This dou u by dou y, I'm going to use minus 2y. Minus 2y. So, with that, minus of minus 2 becomes as minus of minus 2y is equals to 2y plus phi dash of x. That implies 2y gets cancels, then we'll get phi dash of x equals to 0. When differentiation of a function will be 0, whenever that function is a constant, that implies phi of x equals to c, because apply integration on both sides with respect to x. With respect to x, then we'll get phi of x equals to c. Then replace phi of x equals to c in which equation? As one of your friend mentioned, in equation number 3. So replace, therefore equation 3 implies v is equals to 2xy plus phi of x comma y is nothing but c, is our required conjugate harmonic function of given u function. conjugate harmonic function of given function u. Changes, that's enough. Complex potential function, complex potential function. What is this complex potential function? Okay, so for example, I'm taking a function like this. Let w equals to, what is the w we have taken earlier? U of x comma y plus I into v of x comma y. But here I am taking, instead of u, phi of x comma y plus I into, instead of v, I am taking psi of x comma y. Okay, and if it is analytic, if it is analytic function, then it is called as complex potential function. It is also called as complex potential function. So what is a one more name for analytic from now onwards? What is the one more name for analytic function from here onwards? Complex potential function. Okay, another name for the analytic function is complex potential function. Okay, what is its real part? Its real part, phi of x comma y, is called velocity potential function. Velocity potential function. Velocity potential function. And imaginary part, what is the imaginary part? Psi of x comma y is called stream function or flux function. Stream function, or another name for the stream function is flux function. Okay, these are the things. Now here, what about phi and psi will satisfy Laplace equations? Yes or no? Yes or no? Phi and psi both will satisfy the Laplace functions, Laplace equation? Yes or no? Provides a u function, that is a velocity function. When they provide velocity function, they are asking to find analytic function. Now they are going to ask a complex potential function. Is it the process will be the same or not? Same process. Finding analytic function, that is a complex potential function. When they provide real part, that is nothing but velocity potential function. Same manner, finding analytic function, which is a complex potential function, when they provide imaginary part v of x comma y, that is a psi of x comma y. Yes, you can off your cameras and you can sleep. Backlogs post cheyandi, appudu SGPA CGPA idi raadu. Okay, so that is the way we can find out here. These are the things. So for the